Okay, so we're muscles PowerPoint. So muscles let us move. And skeletal muscles, which are called voluntary muscles. And then cardiac muscle is very important, obviously. I know about that because, well, I had robotic surgery January 6th on my heart to put a window in my pericardium. I'm doing much better now. And then smooth muscles because visceral organs, bladder, lungs, blood vessels, digestive system. So what do skeletal muscles do when they attach to bones? Movement, posture, support soft tissues, guard entrances and exits like your anal sphincter, help maintain body temperature by shivering, guard entrances to your uh, esophagus, and so on. Okay, so the gross anatomy of muscle. Okay, so the epimysium, it covers the whole muscle. There's more connective tissue of the fascicle, which sits right on top of the outer layer of muscle, and endomysium uh, surrounds each muscle fiber, which is a single cell. Remember that each muscle fiber is a single cell. And then we have tendons, which connect muscles to bones, and then aponeurosis, which are large sheets of connective tissue that connect muscles to bone. Okay, so the organization of the skeletal muscle. So we said that the outer covering is the epimysium. The whole skeleton is an organ. It's made up of fascicles, which are surrounded by perimysium, and then a bundle of fascicles. A bundle of fascicles. Bundle is made up of a bundle of cells. The whole muscle is a bundle of fascicles. Each fascicle is a bundle of muscle cells, which are long protein fibers that their job is to contract. So, and they are surrounded by the endomysium. So the outer covering of a whole muscle is the epimysium. You have blood vessels and nerves. The perimysium goes around the muscle fascicles, which are bundles of muscle cells. It's each one of those muscle cells that's surrounded by an endomysium. Okay, so remember, a skeletal muscle fiber is a muscle cell. It's a long uh, fiber of protein and has nuclei, multiple nuclei. So let's look at one muscle fiber, okay? So sarcolemma is the cell membrane of a muscle. Sarcoplasm is the cytoplasm. There's a whole sarcoplasmic reticulum, a whole network of connected tubes and sacs. Transverse tubules are openings in the muscle fiber membrane. Myofibrils are actin and myosin, we'll learn. They make up the contractile proteins within a muscle cell or fiber. Muscle cell, or muscle fiber. So sarcomeres is how the actin and myosin or the muscle filaments are arranged in the muscle. And we'll see that sarcomere means flesh part in Greek. So the sarcomere is a repeating structural unit. Muscle is just sarcomere after sarcomere. It's made up of myofilaments, thin filaments actin, thick filaments myosin. Z-lines at each end of the sarcomere, which anchors the thin filaments. So what does that look like? So Here's a single muscle fiber. So it has T tubules which connect into the sarcoplasmic reticulum. So sarcoplasmic reticulum is right here, and the T tubules are connected to allow the flow of various ions. So remember, this is a muscle fiber, it's a muscle cell. It's made up of bundles of myofibrils, which are composed of thick and thin filaments. The sarcomere goes from Z line to Z line. The actin thin fibers, the thin filaments are connected to the Z line. And then in the middle of the sarcomere, there are thick filaments, the myosin. So the T tubules allow, who's got their microphone on? Somebody's got their microphone on. Oh, me is back. Is that me? I hope not. So, okay. So, again, we have the sarcomere, which goes from Z line to Z line. It's composed of a thin filament actin and a thick filament myosin. It's surrounded by the sarcoplasmic reticulum, and the exterior allows ions to move into the T tubules, and they have connections to the sarcoplasmic reticulum. So T tubules, and when you have a T tubule, and on either side you have it's called a terminal cisternae. That's the termination of the sarcoplasmic reticulum right next to a T tubule. That's called a triad when you have a T tubule with terminal cisternae, plural, cisterna singular. Okay. So here's a close-up shot of the sarcomere. The sarcomere is made up of actin and myosin, thick filaments, thin filaments. So here we have the Z line, and you can see that the actin filaments are connected to the Z line. The myosin thick filaments are connected at the M line. The A band is when we have thick filaments, myosin, and there's some thin filaments. So the A band contains thick filament myosin and thin filament actin. The I band is on either side of the Z line where the actin filaments are connected, and that's where we have a sarcomere from Z line to Z line. This is the repeating unit of a muscle fiber. It's where the contraction process takes place. So if you look at a single muscle fiber, there's the Z line, there's the M line, and so the thin filaments are connected at the Z line. The thick filaments are connected at the M line. And remember, each thick filament, the myosin, has these multiple myosin tails with a myosin head. This is a hinge, and it allows this head to move back and forth. The thin filament, the actin, is made up of globular proteins, and it has tropomyosin, which are these long filaments that surround the actin, and troponin is the little modules, and we'll see what that function is. The tropomyosin is the long filament, and so each sarcomere contains a Z line on either side. It has actin connected to the Z line, and then thick filaments are in the A band in the middle of the sarcomere. Notice that these actin and myosin are situated with the, if we go back here, we can see that the myosin is surrounded by thin filaments or actin. So let's take a closer look at the sarcomere. Sarcomere is, again, Z line to Z line. The actin is connected to the Z line, and the myosin is held in place at the H zone by the M line, and this is the sarcomere at rest. So notice the position of the actin, and the myosin has these myosin heads. So what's going to happen with contraction? When contraction occurs, you can see that somehow the sarcomere is shorter now, and the actin has been moved closer to the H zone so that more and more actin surrounds the myosin, and the whole sarcomere has shortened. So that's, with every sarcomere shortening, that leads to contraction. Okay, let's wrap this one up, and we'll save this first video. And multiple people, okay, admit all. Okay, we're going to stop recording for a moment. Stop recording.